Exercise 10.1, question number 3. The question is, there are 2 points, P and Q, whose coordinates are given, the x-axis, y-axis, x-axis, and this is y-axis. And P and Q, we have to find the distance between the point P and Q. Q is parallel to y-axis. First, P and Q are parallel to y-axis. So they will lie somewhere on any line. Suppose this is the line which is parallel to y-axis. And on this line, these 2 points lies, P and Q. So suppose here we can take the point P, whose coordinates are x1, y1, and Q is another point whose coordinates are x2, y2. Okay. We have to find the distance between these 2 points in the first part when PQ is parallel to the y-axis. So PQ, the distance formula, what is the distance formula that we have learned in class 10th? X2 minus x1 whole square plus y2 minus y1 whole square. Okay. But when PQ lie on the same line which is parallel to y-axis, so that means this distance is x1, this distance, x-axis is distance on x-axis. So this distance either x1 or x2, both are same. x1 and x2 will be same because the point is at an equal distance from y-axis. So whether you take this distance or this distance, they have same. That means x coordinates are same. Therefore, x1 is equal to x2. Right? When PQ is parallel, this is the distance formula you use. When PQ is parallel to y-axis, y dash, y dash, then x1 is equal to x2 put above. Therefore, we get PQ is equal to x1 is equal to x2. Then these two will cancel. You can put x1 is equal to x2. x2 minus x2, 0. This will become 0. We get y2 minus y1, y2 minus y1 whole square under the root. And when you put the root, square will cancel. You get the distance y2 minus y1. Okay. And when PQ is parallel to, when PQ, second part, when PQ is parallel to x-axis, when PQ is parallel to x-axis. So for x-axis, any line which is parallel to x-axis will have the point on it like this. Point P, somewhere you will find P point whose coordinates are again x1, y1. So these are 2 questions. And Q, anywhere you can take Q, then Q is x2, y2. This is second question. You should draw the second diagram for second question. Then again, when it is parallel to y-axis, then y1 will be equal to y2. Both are equal, so this will become 0. Therefore, the distance PQ will be equal to under root x2 minus x1 whole square, x2 minus x1 whole square, and y1 is equal to y2. Therefore, y1 minus y2 will be equal to 0. So your answer will be x2 minus x1. Then 10.3, question number 4. Find a point on the x-axis which is equidistant from the point 7, 6 and 3, 4. So let this is an x-axis, y-axis, P be a point on x-axis, x0, any point on x-axis is x0 because on x-axis y coordinate is 0 and A is at an equal distance from P. P to A distance, this distance equidistant because in the question it is given this is equal to this. So these two distances are equal. Find the value of x. Find the point, that means x. So distance PA is equal to PB. Distance formula will be applied. PA will be equal to PB, or you can write squares both sides so that no need to put square root. So formula x2 minus x1. So x PAX minus 7 whole square plus 0 minus 6 whole square will be equal to x minus 3 whole square plus 0 minus 4 whole square. Squaring a square minus 2 sevens are 14x plus 7 sevens are 49 plus 6 6 are 36 is equal to x square minus 2 3s are 6x plus 3 3s are 9 plus 4 4s are 16. This x square will cancel. X terms you take left side, so minus 14x plus 6x. So minus 8x and 9 plus 16, 25 minus 49 minus 36. So minus 8x is equal to 25. 9, 5, carry 1, 3, 4, 5, 6, 7, 85. So minus 8x is equal to 60. Minus 60. So minus minus cancel, x is equal to 60 by 8. X is equal to 60 by 8 and you can cancel 2 3s are 6, 2 4s are 8 or 2 2s are 4, 2 15s are 15 divided by 2. So therefore the required point is here. The required point is P 15 by 2 and 0. This is 10.1, not 3. 10.1. Okay. Now we have to do question number 5. Question number 5. Find the slope of a line which passes through the origin and midpoint of the line segment joining the point. Okay. So we can make the rough figure. This is x-axis and this is y-axis. Okay. And there is a line passing through the origin. This line is passing through the origin and the midpoint of the line segment joining the point. Midpoint of the line segment, another line segment whose midpoint is this one. Suppose this is the line segment whose midpoint is this one. So this is origin, this is passing from origin and the midpoints of the line segment joining the points whose coordinates are 0. Actually x coordinate is 0, so the point will be on somewhere here on y-axis, so 0, minus 4, and the next point is 8, 0. That will be on x-axis, 8, Q point, 8, 0. So this line will come up to here and till here. Point will be here. But this is the midpoint. M, suppose this is M. M is the midpoint of PQ and origin, the coordinates of origin, you know that. And we have to find the slope of this line. Slope of this line. Okay. The slope of this line will be equal to y2 minus y1. We know that the formulas y2, slope of the line, is denoted by m, and its formula is y2 minus y1 upon x2 minus x1. So for this line OM, one point we know we need x2, y2. So this is the midpoint. So you know the midpoint is equal to 8 plus 0, x1 plus x2 divided by 2, y1 plus y2 divided by 2. That is equal to 8 by 2, 4 and minus 2. 4 and minus 2 is the midpoint. So therefore, the slope of required line is equal to y2 minus y1. That means 4 minus 0 and x2 minus y2 minus y1. x1, y1, x2, y2. We'll take x1, y1 and x2, y2. So y2 is minus 2. So minus 2 minus 0 and 4 minus 0. So minus 2 by 4, that is equal to minus 1 by 2. Minus 1 by 2 slope. The slope of this line is minus 1 by 2. Question number 6. Without using the Pythagoras theorem, show that the points, we have given the points, suppose this is A, 4, 4, and point B is 3, 5, 3, 5, and point C is minus 1, minus 1. Show that these are the vertices of a right angle triangle. So we have to find a slope. I told you if two lines are perpendicular to each other, suppose this is a line and this is perpendicular to another line. This is perpendicular to another line. We have 2 minutes left. Okay, I'll try to. So M1 into M2, their slope, product of their slopes, M1 into M2 will be equal to minus 1 if they are perpendicular. So we have to show that it is the perpendicular. These are the slope. If we find the slope of AB, M1, AB will come y2 minus y1, 5 minus 4, 3 minus 4. That will come equal to minus 1, and slope, this is the slope of AB. Then slope of BC M2 will be equal to 3 by 2. Same way you can do it. And the slope of CA M3 y2 minus y1, using the same formula, slope, this will come 1. So now if you see that M1 into M3, that means slope of AB and slope of CA is equal to what? 1 into minus 1, that is minus 1. So which shows that AB is perpendicular to CA. So one line is perpendicular, that shows that ABC is a right angled triangle. The triangle ABC is a right triangle that we have to prove. Okay.